Today we're going to be working on finding conditional probability in our Excel sheets. So we have already completed our kind of journey with your chapter 7.5 conditional probability, where we kind of got familiar with this formula and its opposite counterpart when we're trying to find the and portion. We said we had lots of examples in class. I believe I may have used one that said like, hey, we all know what the Titanic is, whether that we have watched the movie or we are a history person, right? But either way, the Titanic was a ship that set sail, and unfortunately, it hit an iceberg, right? So an iceberg has occurred. So that would be your B here. So something has already happened. So we have hit the iceberg. Now we know at the very end of the movie that the iceberg has then caused this boat to sink. That would be your end action here. The Titanic is now at the bottom of the sea, unfortunately. But keep in mind, it doesn't all occur at once. It doesn't sink immediately. We have to take actions, or we have a series of events that come after that lead up to it. That is this conditional probability. The iceberg has hit your boat, so that has happened already. So that's why it's here. But A here, this is what hasn't happened. We know that it's going to result in something at the very end, but it hasn't happened yet. So we are building up to it. We can see that as well in your decision tree as well. This is that conditional probability tree right here. So B has happened, the iceberg has hit your boat, events are causing your boat to slowly sink, and then by the end, it has then fallen into the sea. So for us, we're going to take not this equation. We're actually going to be using this equation right here. It's kind of opposite counterpart. We're trying to find the and portion, and we are going to be pretty much doing this exact decision tree. Let's say you saw the video game, right? Which we are going to be given in some capacity these values, not all of them. As you can see, we might have to do some negation. But we found this, we were given this probability of B. We saw the ad, and then the events leading up to it, right, to us actually purchasing the ad is about 20%. So we're going to enter that in, and there is a mistake on here. I swapped these two cells on accident. So this should be labeled as B28, and this is B29. So we said that this was 0.125. That is going to be something that's given. So we saw the ad. And the events leading up to it is 0.2, so 20%. And your end result here is going to be equal to B times A. And this branch is 0.25. So this is going to be about 2.5%. And that is going to be the outcome. You saw the ad. You liked it enough that you're then going to put it into your shopping cart, right? Go to the store, put it in your shopping cart, and at the very end, you're swiping your credit card. So you have finally purchased it because of some outward action, so some sort of catalyst. Now, you can, if you want to, do the remaining down here, right? Where you can do all of the opposite counterparts. So it just says the probability of A, and this is actually in this cell, the probability of A not, so not A, given B, the probability of A, and then if you want, you can always just copy and paste, or you can insert a symbol. And then sometimes you have to go looking for it by scrolling through. I've recently used the symbol, so it's down here below, but we're looking for this and symbol, close in B. And keep in mind, this is a, oops, we're looking for not A. Where is my cursor? There we go. Not A and B. And the below, I don't know why that is already there. That may have been a mistake here. But then down here, we have probability of not B, probability of A given B not. And I might just use this, copy, paste, and swap my not. The probability of not A given not B, and we'll copy that back down here. There you go. So use what we've done up here, right, to find the second branch where B has still happened. Your condition has slightly been altered. These are opposite counterparts. And now we can go ahead and figure out, okay, find the end result like you did with here. Now you can do this for the remaining branches to get your remaining totals. And in effect, you will be creating your decision tree. And that was something else as well. Create a decision tree seen on 5.7, page 3 of your guided notes. So essentially this part here, you don't have to put these values, but we're just going to be creating this in your decision tree right here. So in order to do that, I won't do the whole decision tree because we've done that already with your coin toss. So we can insert illustrations, smart art, go to hierarchy, and you can select this one or that one. It doesn't really matter which one you do. If you do this one, you might want to label like your conditional and unconditional event, but you might insert in something like this. You don't have to have this part here, but then you have to use your context of A or B, B, A, or A, not A, that sort of thing. So I will kind of shorten that. Sure. Now your second portion is to test your independence, right? Because conditional probability is some sort of dependence on one another. The first thing has happened, and then the following event depends on what came first. So if we are confused at all, do we have independent or dependent actions? What we know from your notes again, let me flash to your notes here really quick, is that the probability of that condition, right, the second event, could actually be in fact equal to the probability of A, it just happening on its own without regard to what came first. So if that is true, when we go to test independence, we have two ands to calculate, one from your formula and one from some sort of visualization. So if we go and see, okay, if we were to look at the same parity, maybe I don't know if it'll let me get a little bit closer, maybe not. But to test your independence, right, we can have different outcomes or different things that we're looking for. So for us, we want to know, okay, we're rolling two distinguishable dice and observe the number facing up. Find in cell E27, so that is right here, find the probability that the red dice is even. So that would have been right here. The red dice being even, we can either have a red being 2, in which case it results in 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, or the red dice is a 4, or the red dice is a 6. So in total, we had 18 out of 36 ways for red dice to be even, so 1/2. So we can put that right here, 1/2. We did it again with B. Find the probability that the dice have the same parity. They're either both even or they're both odd. So you'll see in green over here, okay, 1, 1, that was one of them. 1, 3, that was another. 1, 5, that was another. 2, 2, 2, 4, 2, 6, 3, 1, 3, 3, 3, 5. And you'll notice that again, it kind of does this checkerboard. And if we were to highlight all of them, we would get 18 out of 36. So again, a half. Now, when it comes to this and portion, this one we are not going to calculate. Instead, we have to logically think it out. Find the probability that the red dice is even and the dice have the same parity. So if we were to overlay these on top of each other, you'll notice that over here, that the red dice is even. And if they both have the same parity, that means that because the red is even, the second number also has to be even. So you'll see that these green ones over here, these are all of the odd ones that we highlighted. Those won't matter anymore. And you'll notice that these pink ones over here, those were when your parity got swapped. So it's even or odd. So for us, we only had 9 instances of overlap between our pink highlight and our green highlight. Something like that would have been 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, and so forth. So we had 9 instances out of 36 or 1/4. So this was 1/4. Now, when it comes to this portion here, the and portion, we're going to take what we had learned about, okay, we are multiplying these two aspects together. So we're going to take equals this E27 and multiply it to E28 and go ahead and hit enter. And you'll notice that these two values are the same. One we kind of had to look at, the other one we could calculate. So in this aspect, these are independent. They are the exact same, so great. Because A happened, that doesn't mean B has to end in a particular result. We could do it again with your following, right, down here, that the sum of the number is 6 and both numbers are odd. Well, the sum of the numbers of 6 is 1, 2, 3, 4, 5 ways, right? 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. So there's 6 different ways of that happening. So equals 6 out of 36, or 1/6. B, and I can hide that here because I don't need it. B is that they're both odd. So you'll see it over here. 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5. So there's 9 instances once more. So 9 out of 36, or 1/4. And then when we overlay these together, you'll notice that only certain ones are highlighted. That would have been here, and again here, and again one more here. So 3 out of 36. So we're hoping that when we do your next calculation, that it's about 8%-ish, right? So we can say equals this value here times this value here. Oh, sorry, that was actually already there. I shouldn't have done that. Right, but you'll notice that because in your last example, it already had that those values calculated, that this value is here. And we can very clearly see that these two values are not equal. Therefore, they are dependent. So whatever came first, let's say the sum of the numbers is 6, is that what we are hoping for? That just means that both numbers are odd, or vice versa, right? So it kind of has this dependent relationship. So that is just to test dependence and independence.